Hello students, welcome back to your science class. So students, in the previous class we were talking, today we will going to start with a new chapter and then that is work and energy students. Obviously, if we are talking about the work is basically what? Anything that we used to do that we called as a work only. And this work is actually equals to the energy. Okay, so you know that every day, day to day life, we used to do a lot of work, and yes, that will include the life processes. That will include a lot of a thing like for doing any of the activities, we need energy. We and for that we used to do the work, like playing is a work, singing is a work, reading, writing, thinking, jumping, cycling, as well as running. All these things are what? These are actually the work. And basically this work, it can be done when there will be a sufficient amount of energy will be there. So for doing any of the activities, it is important, or it is we require that of the energy. Okay, so today we will going to understand that of the work only. Now let us try to understand the work. What is the work? Normally when we use this term in our day-to-day life, in terms of a science, if we will try to understand here, then we used to say that work is what? The thing that we used to do every day, that we called it as a work. Okay, now in terms of a physics, there is a some another concept are there for the for work. There is a some other scientific conception is there of that of the work student, and that is what. Now see here, to understand in this way, we use there are lot of other things, like see it is written here that push a pebble lying on a surface. The pebble moves through a distance. You exerted a force on the pebble and the pebble got displaced. In this situation, work is done. Basically, when we used to push anything, then what happened? The thing get displaced from its place, and in that situation we used to say that it is what? It is actually the work only. Similarly, if a girl is there and she is pulling a trolley, that trolley moving it certain distance, that we called as a work only. Okay, scientifically we use the term for it, and that is work. If we talk about the scientific conception, and by this we have understood here one thing, that when we used to push anything or when we used to pull anything, there we used to say that we had actually done work. Actually that is what, that is the force, but because of that, if the object move or displaces its place, we used to call it a work. Now we can compare the work with that of the force only. As you can see here, it is written that work is equals to what? That is force into displacement. What does it mean? It means that when we used to apply a force on an object, it will make the object to displace from its place. That is what? That is work. Okay, so work is what? It is equals to the force into displacement, that we call as a work. Okay, that we call as a work only. Okay, so work done is equals to what? That is force into displacement. It is work done. Now let us try to understand here about that of the work only, if we are talking about. As you can see here, normally we used to represent the work in joule. Okay, generally we used to represent it through joule only. So work done is what? Work done is actually the amount of a force when we applied in an object, due to which the object actually displaces or it carries or cover a certain distance, that we called as a work done an object, and we used to represent it through joule only. So as you can see here, if we here consider an object is there students, and suppose a girl, she is pulling this car with the help of a thread. So here she is actually applying a force on that of the toy, and because of that the toy actually displaces, or it changes its place, or it moves from one place to the another place. That is called as work. See, if we will say that work is done on an object and if the object does not displaces or does not move from its place, at that time the work done will be zero, because work is said to be effective only when the force is applied onto it and making it to displace it from its place, or making it to move certain distance, that we called as a work only. Now in this one, the thing that we have to understand here, which is really important to understand, is what work is. The SI unit of the work is what? That is joule. Now, when we say that W is equals to what? That is force into distance. So, work is represented by joule, and this joule will be equals to what? Newton, which is the SI unit of that of the force, and meter, which is the SI unit of that of the distance traveled by the object. So, W is also equals to the Newton meter. So, we can say here that what is the definition of the 1 joule. Now, see here, the definition of 1 joule is that if F is equals to 1 Newton and S is equals to 1 meter, then the work done by the force will be equals to 1 Newton meter, right? And that is what? That is the unit of the work, or even we used to represent it through by 1 joule. It means we can say that work can be represented as Newton meter, or work can be represented as a joule also. Similarly, by the help of this, we can also define that of the joule. So, joule is what? Amount of, joule is actually the amount of work done on an object when a force of 1 Newton displaces it by 1 meter along the line of action of the force. Basically, joule is what, student? Joule is a force of 1 Newton displaces by 1 meter along the line of the force, that we called as a that we called as a 1 joule. Okay, so basically when we apply a force on an object of 1 Newton, making it to move, making it to displace 1 meter, that we called as a 1 joule. That is the definition of the 1 joule. Okay, now see here. Now let us try to understand this with the help of this numerical. With the help of this question, we will try to understand the concept of the work, students. So question is that a force of 5 Newton is acting on an object. The object displaced through 2 meter in the direction of the force, and if the force act on an object displaced through 2 meter in the direction of the force, if the force act on an object all through the displacement, then the work done is. Now see here, basically how much force is applied here? It is 5 Newton. And the object is displaced. How much meter it has been displaced, student? That is 2 meter, which is acted towards the direction of the force only. Now, if the force which is acting here, what will be the work done? Basically, we know the definition here to find out the value of the work done. W is equals to force into distance. Now, W is equals to, what is the force here? That is 5 Newton, and the displacement is what? That is 2. So 5 into 2 is equals to 10 Newton meter, or we can say here 10 joule. Both of them will be what? That is the correct answer of this question, in which when we apply a force on an object, it will displace the object to 10 Newton meter to 10 joule. Okay. There are a lot of other questions, students. A question is also there like a force of a question is that a force of a 7 Newton acts on an object. The displacement is say 8 meter in the direction of the force. Let us take it that the force acts on the object through the displacement. What is the work done in that case? Now see here what are the things which is given? Let us try to understand that. First of all, the force is given, student, and force is represented by 7 Newton. Then the displacement is given, and that is say as 8 meter, and this both of them occur in the direction of the force only. Then what will be the work done? Now see here, since it occurs in the direction of the force only, that is why the work done which came out, it came out as a positive. First of all, Second thing, what is the work done now here? Again, with the help of the same formula, that is W is equals to F into displacement, we can find out. What is the force here, students? So the value of the force is given. So W will be equals to, value of a force is given as a 7 Newton and the displacement is given as 8. So 7 into 8 is equals to 42. So the work joule will be what? It will be 42 joule, or we can say here that it will be 42 Newton meter. So this is how we can calculate the value of the work done if the force is given and if the displacement is given, students. Suppose we have applied a force on any of the object, then we will make it to move to certain distance, and this we can say as a work done. So for that we must know the force as well as the distance traveled by the object. Okay. Now, there are some of the conditions that we have to understand here. First of all, see, suppose a situation is there. This is very important to understand here. See, here in this case, as you can see here in this picture, in this figure 11.4, here this girl is pulling that of the car towards itself. Now, what you have understood here? She is applying a force towards herself, and the car is also moving towards herself, towards the same direction. That is why the work done, it came out as a positive. But there are sometimes situations in which the object is moving with the velocity, certain velocity in a particular direction, but there is a force which is acting on the object in the opposite direction, which we also call as a retarding force here. And now, due to which we can say it is a kind of a negative force. Suppose if you want to understand this concept in a better way, suppose you have taken a ball and then you throw it in the upward direction. So due to which what happened, the ball means the force which you have applied on the object, or we can say the direction of the movement of the ball is in the upward direction. But the gravitational force which is acting on the ball is in the downward direction. So you have thrown the ball in the upward direction, but the gravitational force is acting in the downward direction, and due to which this is supposed to be a kind of a negative force which is acting on it. Now, when you will try to find the angle between that of the opposite, these two forces, force and that of the displacement, you will find the angle which is between them is what? It is 180 degree. So let us try to understand this first, that here the force is what? It is in the opposite direction and the movement of the ball is in the upward direction. So a retarding force is acting on it. So retarding force is what? Making it a negative force. Okay, so here the work done by that of the object is supposed to be the negative work done, not a positive work done. So by this we have understood here one thing, that is, if the force acting in an object and the displacement which is occurring on an object, if both of them are in the same direction, then the work done on the object will be the positive work done. Second one, if the work done on an object and if the force applying on an object and the displacement, they are in the opposite direction, so they that kind of a work will be what? It will be a negative work done. Okay, so this is how we can say that work can be positive or work can be negative also. Okay. Now here there are some situations, students, in which we will try to understand about that of the work done by an object. Now let us try to understand this concept in a better way. See, students, what happens? Suppose you can see here. See, suppose a girl is there and she is actually pulling a trolley bag. So when she pull a trolley bag, a force is applied by her in this direction, but the trolley is moving in the forward direction, and because of that, this is a applied force, but this is the direction. Now what kind of a work is done here? So, in such a case, when the force and that of the displacement used to form an angle between these two, then we used to represent this angle as a theta. Theta. And now the work will be represented as W is equals to Fs cos theta. Now the theta basically depend upon the angle which is made between that of the force and the displacement. Let us try to understand this fact also. Now here by this we have seen another kind of a formula, and that is Fs cos theta. It's really very important to understand this. That is Fs cos theta. So see here, Fs cos theta. By this, now see, W is equals to. Now suppose the object is moving in this direction and the force is also applied in this direction. So this was the force and this was the displacement. Now what will be the angle between these two? So you will say the angle between these two will be 0. So now if suppose we will going to apply the same thing here in this formula. So now Fs cos the theta, it will be equals to Fs cos 0 degree. Right, and cos 0 is equals to what? That is 1. So we can say here W will be equals to Fs into 1, or we can say W is equals to Fs. So in such a condition we can say here that the work done is what? It is a positive work done. Right. Now, if we will say here that we had applied a force on a ball, a ball is moving in the forward direction. So this is the direction of the ball, but a force of friction is acting on that of the ball and which is in the opposite direction. Now the angle which is made by this F and S will be what? It is 180 degree. Using this formula, we can write here is equals to W is equals to Fs cos 180 degree. Now 180 degree cos 180 degree is equals to what? That is minus 1. So we can say here W is equals to Fs into minus 1, or W is equals to minus Fs. So minus Fs actually explains that it is what? It is basically the negative force into displacement is what? That is negative work done. So by this we have understood that any of the either the displacement or the force is in the opposite direction, then the work done will be the negative work done. So the angle must made by that of the force and the displacement must be 180 degree. Only then we will get the value of the work done as a negative work done. Now the next one is that is W is equals to Fs. Now what happens? Suppose a coolie is there and he is carrying a bag or luggage on his head. So the coolie is moving in the forward direction and the luggage which is he has kept on his head, it is acting in the downward direction. Now the angle which is made by that of the F and S is what? It is 90 degree. Right? So in that case W will be equals to what? Fs cos 90 degree. And we know that the cos 90 degree is equals to 0. So we can say here that W will be equals to Fs into 0, or W will be equals to 0. Right? So in that case we can say here that work done will be equals to 0. So here by this we have concluded that basically work is divided into 3 types. The first one is the positive work done, the second one is the negative work done, and third one is the zero work done. Negative, positive and zero work done. Basically, when we talk about the negative positive, so here the force is either acting in the same or in the different direction. In case of a zero, the force is acting perpendicular to that of the displacement of the object, that is a zero vector. So this is what this is all about, that of the work done. So what are the things that we have understood by all these students? And that is the first thing, that work is what? Basically when we apply a force on an object, making the object to displace or making the object to move, that we call as a work done. Now by this we can also say here one thing, that is what work done can be divided into three different types. The one is the positive work done, the negative work done, or that of the zero work done. Now, when we used to do the work against that of the gravity, there also a work is done, and that work is represented by mgh. How we can say it will be mgh? The student, try to understand this. Suppose you have taken a bucket which is full of water and you have carried it to a certain height. So you are actually applying a force on an object, and because of that you have take it from one place to another place. So in term of that, we can also say W is also what represented as a weight. We have seen in case of a gravitation chapter, force is equal to what? That is, force is equals to what? That is weight. And we can represent the weight is equals to mg, and the distance which is traveled by it will be represented by that of the height. So W is also equals to mgh. Okay. Now see here, a question is there. Question is that a porter lifts a luggage of 15 kg from the ground and puts it on his head 1.5 meter above the ground. Calculate the work done by him on the luggage. So mass is given here. You can see here in the question itself, you can understand it very well. That is, the mass is given and the mass is 15 kg, and the displacement is given as a 1.5 meter. Now mass is given, height is given, and the g is also given, that is 10 meter. Obviously W is equals to mgh. Putting this value here, we can get the value. So the mass is what? That is 15 kg. G is what? 10, and height is given as 1.5. When you multiply all these, we will get the answer, that is 225 Newton meter, or we can also say that 225 joule. Okay, so this is how we can get the value of that of the work done. Here the questions, I hope you have understood that what is a 1 joule of a work we have just discussed. We have also understood that what will happen if we will going to apply a force in the direction of that of the displacement. Write an expression for it. Obviously the cos will be become cos theta will becomes a cos 0 degree, and it will be a positive work done. Now let us try to understand the very important topic of this chapter again, and that is energy. Obviously, the work that we want to do, any activity that we want to do, we need energy for it. Okay, and this energy is important because this will help us in completing any of the activities. Okay, so we used to say then all the biological processes which occur here, why we used to do that? Why there is a need of a food? Obviously, fuel will help us in providing the energy. So anything that we used to eat, that we used to consume, basically it help in providing that of the energy. So energy is really very important for the survival of any living organism. Let us try to understand that what is the energy. Now let me tell you one thing, that energy is what basically the things with the capacity of doing work is called as energy. Any object used to do the work, basically they used to do the work in order to attain the energy. If there will be no energy, the person will be not able to do any kind of a work. Okay, so we can say here that energy is important for the doing the work. So when we used to do the work, we used to lose energy. And to do any work, we need energy, so we used to gain the energy. Now, so by this we have understood here one thing. As you can see, it is written that energy is what possessed by an object is measured in terms of its capacity of doing work. Unit of energy is same as that of work, and it is represented by the joule. Now joule is what? It is energy required to do the joule of a work. So basically we used to do the work, and this work is actually equals to energy. So that is why the work is represented in joule and energy is also represented in the joule itself. Whatever the capacity we needed in order to complete any work, that we called as an energy only. Now, this energy is also classified into the different forms, and different forms of energy are there. Are a lot of various forms of energy are there, students. It will include the potential energy, kinetic energy, heat energy, chemical energy, electrical energy, light energy. These all are the different forms of energy. The thing which we have to understood in this chapter or understand this chapter is the kinetic energy or that of the potential energy, students. So we will try to understand that of the kinetic energy.